Hey there, TouchDesigner developers. Welcome to another TouchDesigner tutorial. In this video, we are going to look at recreating the screensaver originally found, I think, starting in Windows 3.1 called Mystify Your Mind, and how we can recreate that in TouchDesigner using SOPs and a variety of other top-based techniques to get something that actually looks very similar to what you found on those original operating systems. So if we want to break down this effect, basically it uses a four-sided polygon, which we're attaching different oscillating numbers to the specific points, corner points of that polygon, and moving them around the screen in order to create these shapes that kind of shift between almost like hourglass shapes and rectilinear forms. And I'm sure in the original version of this that was found on those operating systems, these kind of multi-stacked lines were created by having multiple instances of that polygon being drawn, but we're actually going to use some of TouchDesigner's top effects in order to get that that style of effect occurring, just because SOPs are not super efficient to have that many things going on at once. So my replica of this, like the original, has colors that kind of shift over time and does have two separate instances of that shape drawing on screen. We're going to look at just rebuilding one of those first, and then from there we'll take it and duplicate it so that we can get two of them on the screen at once. And then we'll look at how we can modify some of the other features, like how many lines are being drawn at once, or the color, or other sort of related settings like that. So yeah, this is what your final output should look like. And with that, we will jump in and do a brief overview of the network before we actually start building it. So it looks relatively simple from this kind of first look at it. Let me just close the parameter window. Basically, we've got a SOP network with two duplicates of the same geometry being created in base comps here, and then each of those are being rendered with the line material in order to get that wireframe look. And then I'm actually taking the output after it's being rendered and putting it into a bunch of cache tops, or rather one cache top, and using multiple cache select tops to grab multiple instances of that over time. And that's what gives you the layered effect that you see. Without that, we would basically just be seeing the direct output of the render, which looks like this. It's just single instances of those pieces of geometry, but the cache top allows us to get that like pseudo 3D effect. And then finally, I'm just comping a background in, and that takes us to our final output. Within the base comps that are part of this SOP network, however, we're actually using the Script SOP, and we're setting it up so that we have four different points as a part of this polygon, which are actually accessible via a custom parameter page. And then we're using LFOs, a bunch of them in this case, to control these points with individual control over each LFO. I looked at doing this a couple of different ways, which I'll talk about when we build this, but that ended up being the kind of simplest for illustrating this effect with and getting something that looked close to the original. So with that, we will delete our network here, start from scratch, and get to building this thing. All right, so I'm just going to select everything, delete, and then we will get started. So as I mentioned, we have two instances of that SOP network, and that's actually where we're going to begin this, because that's where most of the core functionality of this piece actually comes from. And before we create a second instance of that within a base comp, I'm actually just going to build it kind of at the root of our network editor here within our project folder, and we'll work on creating a single instance first, and then we'll collapse that into a folder and then make a second version when we want to layer those two different polygon shapes together. But as I mentioned, this starts with the script SOP, so we're actually going to grab that first. It's in the fourth column, a couple, maybe 4 or 5 down from the top. And for those of you who've never used this operator before, you can actually write a short, or I guess as long as you want, you can write a Python script that can place points, it can make Bezier curves and a variety of other things, add UV coordinates. You can do kind of all the defining of your geometry via a piece of Python code in this DAT, which is great for this situation because basically we want, as I was mentioning in the intro, we want a 4-sided polygon that we can have discrete control over each one of the corner points of. And so there's nothing really, at least as far as I'm aware, of built-in that has that type of functionality, at least easily accessible. So we can write ourselves a script within our script SOP, which allows us to create that simple geometry and have control over it, and then use some of our other operators to control it. Okay, so you got your script SOP placed down. We have to actually start by writing code. So unlike my previous tutorials, instead of kind of building something first and then adding code later, we're going to start with the code this time. And like the last couple of videos, I'm going to use an external code editor, text editor called VS Codium. If you don't have a text editor or code editing software on your computer that you like, you can always just right-click and hit View and open this as a separate window and then do all of your editing within here. Or if you like, you can also hit the Viewer Active button at the bottom and get access to the code that way. So I'm going to open up this in VS Codium, and you can see here we've got some default code already, which we're going to leave and actually just add to. And we'll look briefly at what this is, what this contains before we start adding to it. Basically, there's 3 sections here, and the first one that we're going to start adding stuff to is called this onSetUpParameters function, which basically, when you press this, let me get back to TouchDesigner here. Okay. When you press this Setup Parameters button here, it will run that portion of the script and do whatever, run this code, and whatever settings or things you're changing within that section will be completed. And in this case, it's actually adding a parameter page to our parameter window here and adding 2 different parameters called value A and value B, which again are being defined, if we go back to the code, via these short pieces of Python code here. So we're adding a page, a custom page to our parameter settings called custom, and then we're adding these 2 different values that we can control. And then later on, we'll actually we'll be able to read in the value of the current setting of these parameters and use those within a later piece of Python code that we're going to use to actually position our geometry. So we're going to take this default code that comes in the script SOP and use it as a reference as we build out our own custom parameter page. As I said, we're going to create custom parameters for each of the 4 points that will make up our final polygon, and we're going to have X and Y position parameters for each one of those points. So that means we're going to have a total of 8 different parameters that we're setting up, and we can start working on creating those now. So we are going to start by changing this first append page.append float assignment that we have here. The way that you have to name these parameters is the first letter has to be a capital, and then everything else has to be either a lowercase or a number. You'll get an error if you don't do that, so make sure that you're following along to the capitalization that I'm going to be using for these parameters closely so that you don't get errors in your own. I'll post the code for this in the description just because there's so much of it, and if you mess up one thing, it'll error out and won't work. So, but anyways, we'll get into writing it out now. The first parameter that I'm going to append here is going to be called point1x. That's telling me this is my first point in my polygon, and it's the x position parameter for that particular point. And then for the label, I'm just going to change it very slightly. We can use capitals and spaces and all that within our label. So I'm just going to call it point1x. And then we can actually copy and paste this one so that we can use it over and over. Okay, so we can copy and paste this. And then we will also want to set one up for our y position for that first point. So we'll do point1y, and then I'll change the label to point1y. Then we'll copy and paste that again. And I'm just going to kind of leave some space in between the different points here because we're going to move on to point2x. And we'll change the label, point2x, and so on and so forth. Copy and paste that again. Point2y. And then I'm actually just going to copy and paste both of them at once now. Leave some space for the third point. And then finally, we will set up the fourth point here. And then we'll save, and we'll take a look at what this has done to our parameter window. So if you haven't seen any of my previous videos, when you're using an external text editor, always make sure to save your code because it won't update in TouchDesigner until it's been saved. If you were using the viewer within Touch or the editing via the operator itself, you don't have to worry about saving, it'll auto update. But now that I saved, those things are showing up here in my script. So if I go ahead and hit the setup parameters button, what will happen is if we come to our custom page, now we'll have sliders for all of those different points. And the sliders by default go from just 0 to 1. And we actually, just to experiment with this a little bit, I think it'd be nicer if we could change the range of those sliders so that they go from -1 to 1, just because we're in 3D SOP space here, and we don't have to be limited to that kind of 0 to 1 range. -1 to 1 would give us a little bit more flexibility as we experiment with this a little bit. The other thing is that the page title for these parameters is called custom, and I'd like to actually modify that so that we actually know what the parameters are that we are modifying. It'll just make it easier if you ever come back to this later on to look at that and know exactly what those parameters are doing. So I'm going to come back to my code, and we're going to change two things. So the way that we can label that page is via this append custom page parameter. There's a string within this called custom, and if we change that to point position values or something along those lines, and then we save and come back to TouchDesigner and run our setup parameters again, now you can see that page has a more descriptive title. And then if we want to modify the ranges of each one of these different parameters that we've added, we have to use another piece of code, which actually I believe you can find within the operator snippets for the Script SOP. There's one that allows you to draw Bezier curves and has some sliders attached to it. And there was a little bit of code there which was helpful for setting up the range of the sliders. And I'm just going to copy and paste this in, but if you need to, if you haven't copied and pasted this code from the description, I'll just make sure to leave some space here for you to type this out, and then we will move on. But basically, we're setting this page append float parameter equal to the variable called p, and then we're reassigning it over and over and over. And the reason why we're doing that is so we can use these two functions that I found in that operator snippet that allow you to set the range of the slider that is found in the parameter page. What this is saying is it's assigning a value for the minimum of that slider and the maximum. And if you're typing this out, it's can see it on screen. It's just P and then 2 brackets with a 0 in the middle, dot norm min equals -1, and then P 0 within brackets dot norm max equals 1. If we save that, and then we come back to TouchDesigner, and we run our setup parameters function again, just click that button, you'll notice that our 0.1x parameter now has a range of -1 to 1. So that's really helpful. So that's the reason why we're assigning this to a variable, so we can use these little handy functions to change the range of those sliders. So I'm just going to set up these ranges for every one of the sliders, every one of the parameters that we've created, and then we'll get back to looking at the rest of our code. So let me I'm just copying and pasting them, and you want to place them after each assignment of this new parameter to P. Otherwise, it won't assign those ranges to the correct slider, or you might miss one. Okay, so we got that all copied and pasted a million times. Let's save. Let's go back to TouchDesigner and run our setup parameters button again. And then now we can see that all of our parameters have a slider which moves from -1 to 1. And that'll, just allow us, as we're experimenting with this, to have a little bit more control and use more of this space that we have here, since these will be corresponding to the actual positions of those points. So now that we have that done, we can actually start writing some of our code where we will actually generate the geometry that we're going to use. So I will come back to VS Codium. All of this will be done within the onCook script or function that we see here. We're not going to use this onPulse function for this example. We're going to leave this script op.clear function call there, and then we are going to do some variable assignments. So the first thing that we have to do within this script is actually read in the values that we will be setting on that parameter page of the operator, so that we can use them within the script and use that for the positioning of the geometry. So what we're going to have to do is, for each one of those parameters, we're going to have to set those equal to a variable, which then we can use within Python. So this is going to take quite a while to type out. So I'd recommend, again, copying and pasting it, but we can at least walk through the first one here so that you can see what is going on. So the way that I set up these variables, might not be the best way, but it's at least readable and short and sweet and to the point. I called each variable P for point, and then the number of the point, and then whether or not it was an X or a Y point that we'll be assigning. So for the X position of my point number 1, I'm using the variable P1X. We're going to set that equal to something which will grab that parameter value from our parameter window, and that is called script op .par .point1x .eval open and close parentheses. What this is saying is there's some kind of built-in function here which we can grab a parameter that we've previously assigned here, which you can see is using the same name that we found in the parameter appending that we did above, and then when we evaluate it, it's just pulling in the current value of it whenever this script is run. So we're going to have to basically use this exact same formatting 8 times in order to get all of the different variables into our Python script. And this, again, is all coming from that example in the operator snippets, which use the same sort of functionality for the Bezier curves. So we're going to copy and paste that 8 times and then make our adjustments. Again, it's a lot easier if you just grab this from the video description, but I guess I will run through it here in case some of you are actually deciding to type this out. All right, P1Y. So you're going to want to make sure you change both the variable on the left and the variable that it's calling to on the right. And make sure those are all set up correctly. Might even add some spacing in between these so we can really have some clarity as to which ones are which. Okay, so we've got all of that set up and it looks like it's all done correctly. Now that we've got that done, I'm going to put a little note to myself here that we are assigning our custom parameters, I guess our position parameters, to variables, and then we can move on by adding that four-sided polygon. So we're going to start by setting up a variable called poly, and we're going to set that equal to another different script operation which we haven't seen before. So again, we're going to use that same type of function call that we saw earlier. This one's going to be called append poly, and that allows us to create a polygon. We can then, within some parentheses here, set the number of points that we want, and that is 4. In this case, you could create a triangle with 3, or multi-sided shapes with more than that. And then we want to make sure that this is a closed polygon because we want all of the sides of this polygon to be connected. So in order to tell it to make a closed polygon, we have to set closed equal to true. And that's it for that line of code. Then we're going to have to set up point positions for all 4 of the points in this polygon that we've just created. So in this case, we're going to use a technique that's found in another one of the operator snippets for the script SOP that allows you to create a triangle with specific point values. So what we're going to do is we're going to type in p equals poly 0 within brackets dot point, and we don't want the point to be uppercase, even though it just auto-corrected that for me. So what we're doing here is we're referencing the first point within this polygon by using the index number of 0 here. And then if we use p.x, we can set an x position value for this point, which we're going to grab from one of these parameters up here. So this is our point number 1, so we want to grab p1x that we assigned earlier. And then we can do the same thing for the y position of that point by doing p.y equals p1y, which again we set up here. We'll continue by doing this for all 4 points. So you can copy and paste this, and then within our index parameter here, we want to look at number 1 for the second point, and then so we're reassigning this p variable over and over just so that we can quickly assign x and y values to each one of these specific points within our polygon. So this time I'm going to want to set the p.x and p.y to p2x because that's the point number 2, and p2y for the y point. And then we'll just continue on by copying and pasting that twice more, and then making those slight changes in order to get those points assigned correctly. So your third point is going to be using index number 2, and make sure to assign those to P3X, and then the fourth point we'll use index 3. And then we want to use P4X and P4Y. So, you know, since we're using kind of computer science or coding counting here where the indexes start at 0, you could have gone through this and named these like P0X for the first point and so on and so forth, just so it's easier to understand which one of these variables is supposed to go with which point, but we've already set it up that way, so that's okay. It'll still function just the same. And with that, we've completed the code for this script SOP. We could have continued by assigning UV values, which are what you can use as you start to texture and light this, but we're not going to be using lighting in the case of this piece of geometry. We're going to be using the line material, and so there's not going to be really any shading going on. There's also not going to be any texturing going on because we're just going to have a solid color applied to the whole thing. So I didn't really feel it necessary to do my UV assignments within here, especially since the shape is going to be moving and changing. And we're only using a wireframe instead of actually like a surface. So you could do that. It might be more efficient to do that. I'm not sure. The way that I approached this is after I wrote my script, I came back into Touch and nothing, you can't really see anything right now because these parameters aren't set correctly. But if I start moving them around, you can see we're starting to generate some geometry, which is great. And in order to overcome that UV issue, basically what will happen is if you don't do this, when we eventually render this, you'll get an error. I just dropped down the texture SOP after it, and that automatically will calculate that information for me, and then I won't have to worry about getting an error later on. So yeah, we've got a functioning script SOP here, which allows you to move the points around and automatically generates geometry based on that information. We can finish up the SOP portion of this network by just adding a null in case we want to do anything else with this later on. And then we will eventually be encapsulating this as I mentioned before, but we are not going to be doing that yet, so I'm not going to worry about it at this moment. But later on, we might be adding an out to this network as well. But we want us to continue now by adding those LFO chops to control the points within this piece of geometry that we've generated. So let's go ahead and start working on that. For those of you who don't know, SOPs are calculated on the CPU and thus are not always very efficient. And doing positioning or change to the geometry via the SOP is usually not the best way of doing things for the sake of performance. However, I wasn't really able to find a good workaround for doing this other than actually modifying the geometry directly. I thought about approaching this via like a corner pin and using top 2D images or textures instead of working this way, but I found that this method actually gave me a better output. However, the performance sometimes leaves a little bit to be desired. If you've got nothing else running on your computer and you've got a more modern computer than mine, it's probably totally fine, but my computer sometimes will kind of struggle when I'm multitasking like I am now, recording this video and doing this at the same time, trying to calculate all the stuff that's going to be going on within the SOP. But with that little aside, we will continue by creating our chop network. So we're going to need 8 different LFOs to modulate the position of each one of these points. I looked at doing this via the beat chop, which for those of you who don't know, you can get similar signals out of that are, look exactly like the things we get out of the LFO, but you can start to set up multiple channels, which can all be synced together in different ways. The problem that I found with this is because they're all synced to the same clock, so to speak, that we end up with shapes that kind of repeat themselves because the oscillation time of the LFOs are all the same, you'll end up seeing the same kinds of shapes, or it can get stuck in these modes where you'll just have a rectangle rotating around your screen. And so you don't get that kind of constant morphing and changing that we saw in the original. And I found that it's easier to just get that kind of functionality by taking a bunch of LFOs and slightly modifying them so that they're not all exactly the same, and using that to control the positions. So I'm just going to copy and paste this 8 times, and then we'll look at modifying the parameters of each one of those ever so slightly so that we get different kinds of oscillation for those points within our geometry. Now I've got 8 of those down. We can start to modify them. I found that actually the default value of 1 for the frequency is a little bit too fast for the kind of motion that we're looking for. And so I set all of these to start to a frequency of 0.06. You can select all of them and then punch that in, and it'll apply it to each one of them individually. And that'll give us a slower and smoother movement pattern on the screen for our geometry. Then I went into a couple of them and modified the frequency slightly. Some of them I reduced it a little bit, and some of them I increased it a little bit. So you can just kind of at random go through and make some changes. It doesn't have to be a lot, just some subtle differences in speed. And then I also even went in and like modified the phase of some of them, so that if they're ever all kind of reset at the same time, we won't end up with the same kind of synced up oscillations. And then we can come back and tweak these later once we actually see how it's affecting the geometry, but I'm just going to stop there for now. Then I'm going to merge all of those into a single chop via the merge chop, and now we've got 8 different channels all oscillating. Looks like some of them are a little bit too close together, so I probably will have to go in and make some more changes, but that's okay. I renamed all of these chop channels just for clarity via the rename chop. The rename chop makes it super easy to rename a bunch of channels at once. I just went in here and typed in the same names that came from our code: P1X, P1Y, P2X, P2Y, P3X, P3Y, P4X, P4Y. And that allows you to rename all of the chop channels to something that is a little bit more legible for us. Drop down to null at the end, and I renamed that null to position null, because that's where we get our position values from. And then we can use that to make chop references to our script SOP here and get this thing starting to animate. I'm already pretty significantly dropping frames here, so I'm not sure if the performance of this will look that great for the video, but that's okay. We will move ahead anyway and see what happens. So assuming you've got your position all dropped down and are ready to make some chop references here, click on the script SOP, bring up the parameter window, and we'll start to make those references. Just going to follow the exact order that I've set up here and assign those to each one of these things, within each one of these parameters within our window. Just go through and make all of those chop references. And then after that, we'll take a look at our geometry. I'm just going to double check by opening these to see if they all match the specific point I'm looking for. And they look good. So let's take a look at that geometry. So we're getting that kind of undulating shape. And if we were to look at the wireframe of this, we might already have something that looks like what we are looking for. So if you hit the W key when you got the viewer active switch on, you can see the wireframe, and you can see that the shape is already looking very similar to what we had in that very first example at the beginning. We might have to make some modifications once we start to render this and look at how it looks with color and with those cache select tops that we'll look at later on. But for now, it's functioning. We got these parameters shifting, and that's good. And I think we are good to continue on with the rendering portion. Okay, so go ahead and connect a geo comp to the null here that we've set up for our SOPs. We'll grab that, and then we will grab a camera comp. And we also want to get our material prepped as well. So we're going to be using the line map for this. And we're going to be changing the colors within this line map. But first we want to assign this material to our geometry here by dragging it over top that geometry and clicking parameter material. You'll see now we have a wireframe of that geometry we created earlier. And if we were to drop down a render top now, we could look at this in top form. We might have to make some adjustments. Let's grab a null and look at this in the background. Okay, so it's already looking pretty good. Our line is maybe a bit thick and obviously not changing color like what we found in the original, but the shape itself seems to be, you know, kind of unpredictably oscillating between different shapes. It doesn't seem to be staying in any one kind of configuration over time, and that's good. So with that, we can get on to our material. The way that I approached assigning color to this was I used a noise top, and then I converted that to chop channels with the top 2 chopped, and then I assigned those chop channels to the line near color within the parameter window for the line material. There might be, you know, there's 1,000 ways to do this, that some of which might have a little bit better performance here, but to try to alleviate some of those performance issues with the noise, I just made my output resolution 1 by 1, so we get a single pixel of information, because we don't really need any more than that to apply color to the entire piece of geometry at once. We don't have any kind of shading or gradients going on, so I think that will be enough. And of course, that's calculated on the GPU anyways, so we don't have to worry so much as we do with the SOPs about performance. But nonetheless, so once you've got your noise dropped down, I just changed the resolution to 1 by 1. And then within the transform page, I added an ABS time .seconds expression, and I multiplied that by 0.05 so that it wasn't changing as quickly as you see now. And of course, we want this to be color as well and not black and white. So we turn off the monochrome switch on the noise page to get some color out of this thing. So now that that's done, we can add a null. Sometimes you might want to adjust the brightness or some things within this, so I usually will add one of those just for good measure. And then from there, grab a top 2 chop and get the RGB channel information within this chop. One thing that I changed here was I changed the crop to look at a single pixel instead of a row of pixels. There is only 1 pixel anyway. I don't know if that really makes a whole lot of difference with the performance, but I thought that I would at least make that change in hopes that it would give us at least a little boost from trying to calculate more than that. Now that we've got that set up though, we can come within our line material here and make the chop references from this top 2 chop. And I'll grab the RGB channels from that. And now we should have, if we look at our line, a line that, or our polygon rather, we should see a polygon that changes color slowly over time and oscillates through, you know, a variety of different colors. We're still gonna have to work with our line material though, because our line is a little too thick and the corners are slightly rounded, and that just comes from the default settings of that material. So to get those corners of our polygon shape here to be square instead of rounded, we have to change a couple of settings here within our line page of this material. We want to change the start and end cap type to square. And then we also want to change the joint type here to miter. And that'll give us a more like hard-edged corner instead of a rounded, smoothed corner to our line on the screen. And from there, we want to change a couple of other things. Because we don't really care about the Z distance of this thing away from the camera and the kind of shading or change in color options that the line material offers us in this particular situation, I'm going to turn this specify line far color off. You'll see that it will kind of brighten up your color a little bit here. So again, we don't really want to use that distance attenuation for anything else here either. So one of the things that I did was change the distance values for the near and far to be the same. And then the line width that I ended up settling on was 1. And that will give you a kind of thinner line output that looks a little bit closer to what we saw in the original. You could also set the width far to be 1 as well. It shouldn't have any effect now that those are set to the same thing. And with that, we are actually done with that material. So we basically have already what we need to generate the exact kind of effect that we looked at the beginning. However, we need to do a couple of things in order to make it look even closer to what is found in those old operating systems. And I approach this by using the cache top. And the cache top allows you to store a series of past frames in memory and then recall them via the cache select top. And then we can use those and composite them together to get views of this geometry at different points that are slightly staggered in time, which will give us a very similar effect to what we saw in the original screensaver. So what I'm going to do first is you can actually connect directly to the cache top and it outputs the same signal that's coming into the input. So the first thing I'm going to do is place down a null as my first output of this operator. And then I will start using the cache select top after that and eventually composite them together to get the final image. So now that we've got our null placed down, I will also go ahead and grab a composite top, place that here. We'll set the mode to over. And then I can start using the cache top to pull those frames from the past and composite them in. So the way that I'm going to approach this is I'm going to take one, create some settings, and then copy and paste it so that I don't have to do the same adjustments over and over and over. So the first thing that we want to do is point it to our cache top that we want to grab the frames from. Now that that's set up, I'm just going to auto fit it, and then I'm going to use a little expression within the cache index here to make it so that each successive copy of this operator will have a frame value that's slightly less than the previous one. We're going to use something here called me.digits, which for those of you who don't know, grabs the number from the end of the name of the operator. And then me.digits, and then we're going to multiply that by -5. So the first one here will be set to look 5 frames in the past, and then if we copy and paste it, the next one will be 10, 15, so on and so forth. I did a total of 6 copies of this for the version that you saw at the beginning. And you can add or remove these cache select tops basically to get more or less layers to your final output. The original screensaver, if I remember correctly, had the ability to adjust like the number of copies or the number of layers, as well as the color, I believe, too. But in this case, we're kind of presetting that by setting up a select number of these cache select tops. Select all of those, connect them to the composite, and we should get an output that starts to function like what we saw at the beginning. Mine is lagging and glitching out a little bit, so you can see that the cache tops aren't really able to keep up that well. But if you were not recording video and having multiple instances of TouchDesigner up at the same time, you likely would have a very smooth 60 FPS version of that screensaver ready to go. Let me just make sure my final one here is set to 30. I'm even going to reduce my cache size down by 2 frames just because. And so what we can do here to finish up this first part is composite in a background so that we can not have our kind of transparent checkerboard behind this image and look at it a little bit more closely. So you can do this a number of ways with the transform or a constant or something else, but I'm just going to do the constant, composite that in, set that to black because I think it looks better, and we want to make sure our blend or our operation within the composite is set to over. Now we're getting something that looks more like the original. I'm going to hook up an out so we can view this in perform mode and hopefully get a little bit of better performance out of this thing. Looks like my window settings are already good to go. So let's take a look. Okay, so now we're getting a little bit smoother output from this thing than what we saw originally. And it's looking pretty close. It really captures that same kind of shape-shifting effect that the original has. Everything really smoothly animates around the screen and the colors shift nicely. I think the colors shifted even slower on the original version. And I was doing a little research, and I think it was only in Windows XP that they finally added the ability for the colors to shift, whereas the older versions don't actually have that capability. So if you wanted to recreate something even more authentic to the kind of earlier Windows 3.1, 95, and 98 screensavers, you could just set a constant solid color within the line material instead of doing that noise top to chop technique that I covered. This is really cool, and this is really close, but the original had the ability to have multiple instances of this shape generator running at the same time, and we're going to look at how we can recreate that, and we'll kind of have to see about how well it's able to perform as I'm multitasking here, but I'll at least walk you through it so that you can get an almost exact replica of what that screensaver looked like. So we can jump into that now. So the way that we're going to approach adding a second one of these polygon drawing components to our program here is actually going to be done via duplicating this SOP network and adding a second geometry along with a second material, feeding that geometry, and then using the same camera and having them both render in the same render top at the same time. As SOPs run on the CPU, duplicating this SOP network and adding all of these different controls via the chops a second time may affect the performance on your particular machine, depending on how old it is, what kind of processor, graphics card, so on and so forth. So your mileage may vary, but I wanted to show you how to do this so that you can really replicate the kind of effect that the original screensaver had and get an output that I think is pretty interesting and cool. So the way that I did this was I basically encapsulated both the chop network and the SOP network into one base comp. And then I duplicated that and set up my second render pipeline below for that second set of geometry. So what I did was I just moved all of these things over in space, and then one thing that we will have to do is add an out SOP, but I'm not going to do that yet. We'll select all of that. And again, that's everything in this chop network and the script, texture, and null SOPs, and not the geo or any of this other stuff. Then we right click in an empty area of the network and hit collapse selected, and all of that has been put inside of a base comp. Since this was connected to this geo already, it has placed an out top down for us automatically. However, since our original network here had an operator with the name out1 already, if you were to turn the little viewer flag on in the upper left of this base comp, you'll see nothing, and that is because it renamed this out SOP to out2. So you could approach this by renaming that to out1, hitting enter, and you'll now see it here, or you could come to the common page and tell it to look for a different operator within this operator viewer parameter. But now we've got that set up, we can actually just copy that base comp and get a duplicate of all of that functionality. And very likely we will see on my machine, since I'm multitasking here, a drop in frame rate, but let's give it a try. So I'm going to copy that base comp and place it below. And then I'm going to grab, I'll just actually place down a new geo so that the settings aren't applied by default. Cool, so now we've got our second geo. And along with that, I need a second material so that this polygon has a different color from the other one. And as I was saying before, you could just set your color to a static color within the line material, but we're gonna do it via the noise system that I set up here so that we get two different colored lines that will oscillate between colors. I'm gonna first assign this line mat to this second geo by dragging it on top and hitting parameter material. And then I also need to redo the chop referencing for the color, because right now it's still pointing to the original network that I had above. So I'm just going to move this down a little bit and then re-reference those RGB values within that line material. And now they're still the same because we need to change our seed on our second noise. So I'm just going to put that to something at random. Hopefully they'll have some different colors from each other. And what that should have done is place that second copy of the geometry within our render, and we should be able to see it on the screen. To get more layers in this image, all you have to do is just add more cache selects and then connect those to this composite. And when you do that, you'll see now that we should have a total of what, 9 layers? 9 layers. And it's kind of lagging a little bit due to my camera, or my screen recording, but let's see this full screen and see if we can get any better performance out of it. So you can continue adding those cache selects and get even more layers to the thing. Oh, and actually I realized these cache selects are currently not doing anything, because when you place these down, what's happening is that the cache index that it's looking for is actually a higher value than the current amount of frames that it's storing. So let's look at our maximum one here. Okay, so this one, the 9th one at the bottom, should be 45 frames behind our current frame, and our cache size is only at 30. So if we set this to 45, hit enter, and once you make those changes, now you should have 9 instances of those polygons rotating around your screen. That's how you would continue to add layers. You could continue and have tons and tons of the cache selects until you get something that basically covers your screen. You could continue adding more geometry via those SOP networks, although, as I was saying, your mileage may vary with the performance of that, but I think that there's a lot of experimentation that can happen with those things. One thing that I did want to mention besides that before we close out here is that if you do end up recreating this network for yourself and then record and post the results to social media like Facebook or Instagram or even on YouTube, use the hashtag tdmystify, which should be showing up on screen now, to tag your work so that we can start to see what different people have created with this technique. As always, like and subscribe. This has been another TouchDesigner tutorial. I'm going to be continuing to make these TouchDesigner tutorials over time, so make sure that you subscribe to keep up with the latest that I'm posting. And if you're interested in seeing what I'm up to on a more day-to-day basis, follow me on Instagram at Jack Delora, same name as this channel. And you can see my kind of daily experiments as I'm creating video content and other things. And if you run into issues as you start to build this network, just leave a comment and I will do my best to try to help you work through that. If you have any suggestions for future topics or even further explorations within this video's content, feel free to leave a comment as well. And again, I look forward to seeing what everybody does as they start to work with this technique. I hope you have fun as you build it. I think it's a really interesting and cool look at some of our kind of vintage pop culture and computer graphics from the early days. And I think, it'll be great to see how we can take this in 2021 and really push it way further. So with that, I will close out this video. Again, like and subscribe, and I look forward to seeing you in the next one.